Okay, guys, we're finishing up here with the seasons and how we draw them out as a model of our solar system. We're looking here at a few questions last Monday, and I want to answer those now. Essential things that you should be able to answer to date. So the first thing there is describe how the day and night cycle works on planet Earth. And you should have an answer there which states that the planet Earth is rotating every 24 hours. So that means that one hemisphere is facing into space and one hemisphere is facing towards the sun. So that's the reason for that one. Recall the angle of tilt. So the angle of tilt is 23.5 degrees from the vertical, I suppose, imaginary line. The next thing then is identify a similarity between the orbit of planets around the sun and the moon around the Earth. Well, the one thing you could say there is that both of their orbits are counterclockwise. You might have mentioned there, I suppose, that there is the reason that they are orbiting in both cases is because of the gravitational pull between the celestial bodies and the momentum which is keeping those planets on their orbit. Those would be two things there you can mention. So again, you can mention that it is a counterclockwise orbit in both the cases of planets around the sun and the moon around the earth. And you could also mention, as I said, the way the gravity is pulling on both the planets towards the sun and the moon is being pulled towards the earth. When momentum is keeping those satellites, all of them are satellites if they're orbiting something, in orbit around whatever celestial body is bigger than them. And finally, the last question there, explain why temperatures are different across the globe because of the seasons. Well, the reason the temperatures are different, there's a number of things you can mention here. You could mention the fact that there is the planet tilted away from the sun in the northern hemisphere when it is winter. You could say the planet in the northern hemisphere is tilted towards the sun when it is summer. And you could mention things like, for example, direct sunlight reaches the equator. So there's a greater light intensity compared to the, I suppose, northern and southern poles where they receive very little light rays by comparison. So where do we want to go from here? Well, I'm going to be asking you to practice drawing out this particular diagram here, which is a representation of the sun, or rather the summer in the northern hemisphere. Note the position of the Earth when it is summer in the northern hemisphere. It's to the left of the sun, okay? Don't forget the counterclockwise orbit, and there's other things there as well, like, for example, the axis of tilt, and the fact that we have the two north and south poles represented. As I say, this is not art, okay? So we're not expecting a beautiful picture, but we are expecting something that we can recognize that makes sense. So, in relation to the seasons, what else should we be aware of? Well, I suppose one thing to be aware of is that seasons don't necessarily happen on other planets in our solar system. Um, because of tilt, tilt is what causes the seasons on our planet. Okay, and another thing to be, I suppose, aware of is that seasons on Earth and seasons on different planets, if they do happen, are different lengths. So on Earth, we know that is 365.25 days for a year to pass, whereas on other planets, it is either usually it's much longer. You could be talking in the order of years for a season that happened on another planet compared to Earth, which is obviously it's around 3 months. So in relation to four different terms that could come up, they are the summer solstice, the winter solstice, and the spring and autumn equinox. Okay, and what are they? Well, the summer solstice is the point in time when the planet is tilted at its maximum towards the sun. So after this point, it's going to start its process of tilting away from the sun. And that's going to lead into autumn and eventually into winter. So because it is at its maximum tilt, it is the longest day of the year. So you have the most daylight that particular day, and hopefully nice sunshine breaking through. Maybe hopefully no clouds. A nice summer's day in June. So that would be a June time of year. So the summer solstice happens in around June in the northern hemisphere. Okay. Obviously, it's different than for the southern hemisphere because, as we said, um, whilst summer is happening in the north, winter is happening in the south. So the winter solstice, then again, if we're talking, we're just going to focus on what's relevant to us, which is the northern hemisphere. The winter solstice is the shortest day of the year, and again, this is because it is at its minimum tilt. So basically, at this point, um, it cannot be more tilted away from the sun. Okay, the northern hemisphere. So from this point onwards, it's going to start tilting towards the sun, and that tilt towards the sun is going to lead it into spring and eventually into summer. So that is, I suppose, a historical phenomenon that has been recognized by our ancestors. And we know that solstice is celebrated, for example, in places like Newgrange. It's interesting when you look at the history of this. Our ancestors knew a lot more than you realize. An equinox, equi for equal, means that basically the tilt is about equal. Okay, so it's about the halfway point between maximum tilt and minimal tilt. Remember, minimum tilt means basically that you're experiencing winter. Maximum tilt means that you're experiencing summer. So if it's about halfway, well, then you're neither here nor there. So this basically it explains for us our spring, okay, and our autumn. So the temperatures tend to be actually quite similar in both of those seasons. So, is there anything else to this? I think no. We have our diagrams here again. Just shows us the different positions here of the planet in relation to the seasons. Okay, and I think that's the main things there that we were looking at, right? So one thing maybe that you might be interested in checking out is the seasons. So what seasons would you find right now at this time of year are happening in Canada, for example, in Japan and Australia? Is it day or night? Okay, and again, you can check that out. There is loads of information there on that. Okay, I'm just going to pop out of this, and I want to show you a simulator here, which we can use here for looking at the Sun and Earth Moon system. Okay, well, if it loads up for me, I'm going to pop off this again. Oh, it's working there now again. Okay, so this is on Khan Academy, and this is it can be kind of useful, guys. So let's have a look at this and try and study what's going on. So this is a very quick diagram. You can see here that basically the Earth is flying around the sun. So this is the Earth, and we can see it is tilting. Okay, we can see that there's an arrow representing the light going towards the planet Earth, and what's interesting here is that this happens all the time. Okay, so basically, we know that there's continuation in that once one revolution happens, then the Earth will start revolving again around the sun. Okay, you can see the light intensity though. So let's have a look at the northern hemisphere. So we're looking here at the Arctic. Okay, so when is when is the light most intense in the year? Okay, and you can see the light intensity changing as the year goes on. One thing to note though is the equator. Look at the equator, how little it changes. I mean, it changes very little by comparison to the Tropic of Cancer and the Arctic. Okay, I'm not sure where the Tropic of Cancer is actually, by the way. You might want to research that for me. But you can see here that you can understand then why life has evolved really, I suppose, well at the equator, and why there's so many living things surviving in the equator, because the light intensity is basically the same all year round. Okay, So, your work for today, well, will be looking at writing up a bit of notes for me, and we might give you a few questions as well. In the next lesson, we will be looking at the lunar phases. Okay, so be prepared to be talking about the even the exploration of the moon as well. So big events happened years ago when we made it to the moon. So we'll be looking at that.